Hi again. Today we're looking at amine reaction. Hey, this is actually the last reaction. Okay, believe it or not, we made it through the last reaction. But then of course we're not done. We still have to look at some organic graphs next week, and then this course is complete. There's nothing else for me to tell you. That means there's going to be a test coming soon. All right, let's take a look at amine reaction. Now, before we do amine reaction, let's do some properties again. Okay, let's do some properties. And again, this property is going to be based on boiling point. All right, so what I have here are alkanes. And this is ethane. And the boiling point for ethane is negative 89 degrees Celsius. That means it only takes negative 89 degrees Celsius for ethane to boil off. Meaning, what do you mean by boil off? Meaning to break the intermolecular forces between ethane and ethane. Okay? So it doesn't take much. Now that's not surprising because as you can see in terms of this molecule, there's no hydrogen bonding sites. The only intermolecular force that you see here are those London dispersion forces, and we know how weak they are. They're weak. Now, if you were to increase the chain length, do you remember what happens to the boiling point? Now, it's pretty obvious. By increasing the chain length, you're increasing the number of London dispersion force. In this case, because there are more forces, you better have more energy. So the boiling point actually increases. And it actually increases by a lot. Okay? Every carbon that you added will actually increase the boiling point by around 40 degrees. So by the time you get to butane, you're looking at 0 degrees Celsius. So it takes 0 degrees Celsius. Okay, you're looking at negative 273 degree Kelvin to break apart the intermolecular forces behind these butane. Okay, all right. How does that compare to amine? Well, let's take a look at a one carbon amine. Okay, methylamine. The boiling point for methylamine is actually negative 6 degrees. Now, whoa, negative 6 degrees. That's a low boiling point if you think about it. But compared to alkane, it's actually pretty high. Okay, from negative 89 ethane to negative 6 for methylamine. Well, that's not surprising if you think about it. Is there hydrogen bonds behind methylamine? Yeah. What do you think these NHs are? Okay, and there's two of them too. There's one here, one here. These NH obviously are hydrogen bonding points. And hydrogen bonds are far, far more stronger than London dispersion force. That's why you need more energy to break those nitrogen bond apart. Okay. All right. So by increasing the chain length, we know the story here. Okay. More London dispersion force than here, so therefore you better supply more energy. Let's do one more. Okay, a 3 carbon amine. You're just gonna get, of course, more intermolecular force to break, so therefore again more energy. Now, what about alcohol? If we were to compare this with alcohol, let's make another column for alcohol, or let me just put it down here in blue or something like that. Methanol. Okay, methanol was actually 65 degrees Celsius, if you remember. Okay, from the beginning of the week. That's actually a lot higher than methylamine. Okay, both of course has one carbon methyl group, but an OH hydrogen bond is actually stronger by a lot than an NH hydrogen bond. Now, I'm sure you guys know the reason is because the difference in electronegativity between O and H is actually higher than N and H. Even though there's two, this guy still talk louder because it's going to be stronger. So these methanol hooking up together via these hydrogen bond will require more or higher energy to break. All right, so that's properties of amines, or just properties in general, just having amine involved. So something that you should keep in mind. All right, let's go on and look at the reaction of amine. Example 1. Okay, this is always the preparation part of amine. How to make an amine? Well, to make an amine, the main ingredient, of course, is ammonia. Okay, because ammonia is the most basic or nitrogen-containing organic compound, NH3. If you were to react ammonia with some sort of alkyl halide, okay, you're going to get some sort of primary amine plus some sort of what we call H halogen. This H halogen could be an acid or it could be a gas. Who knows? Let's take a look at how that works. Let's draw ammonia. Let me draw some structural diagrams. Here's ammonia. Here's an alkyl halide. So let's draw chloroethane. Now, where's the reaction here? Well, the reaction in this case, of course, is H and Cl will get together. Now, it doesn't matter which H. No, it doesn't matter which H. Any of the H are fine. Okay? Just make sure it connects with a Cl to form HCl. Okay? So that's your H halogen. Right there. HCl. Now, let me just erase this for a sec. Whoa, look how big that eraser was. Okay, let me just... Why did I do that? Let's erase this H. Let's erase this Cl. As you can see, this N is missing a bond. This C is missing a bond. Now, it only makes sense that they bond with each other. Let's show that happening. Okay, plus there you go. Okay, ethylamine. Right, a primary amine, nonetheless. Now, just a little recap in terms of what is a primary amine. A primary amine is when nitrogen is connected to one carbon. That's a primary amine. Okay. All right. Hey, let's keep this party going. Let's not make it stop. Let's take a look at how special is this primary amine, shall we? Let me draw this primary amine down here. Let's draw this ethylamine. Okay? Because if you take a primary amine and you react that with another alkyl halide, what you're going to get is a secondary amine. Plus another H halogen. So let's show that. Let's put together another chloroethane. Okay? HCl is going to form either this or either this. It really doesn't matter. Okay? Just give me one of them. You're going to get HCl and you're going to get this. Okay? That is a secondary amine because the nitrogen is connected to 2 other carbon. Okay? And the name for this guy was diethylamine. Okay? Alright. Is this party gonna stop here? Oh no, don't let this party stop here. Let's continue. Here's your diethylamine that we just prepared from the last reaction. And let's react this with another alkyl halide. Hey, another chloroethane. So you have a secondary amine reacting with another alkyl halide. Now, by, I guess, patterning, you can see that you're going to get a tertiary amine plus another H halogen. Okay. Well, to get that tertiary amine, okay, you can see that, or H halogen, you can see that this Cl is going to hook up with, oh, I don't have a choice here. I only have this H to choose from. There's your HCl. And of course, I will also have this mess. Okay, I will also have this tertiary amine. Okay, so this is your triethylamine. Triethylamine. Okay, so why tertiary amine? So just a little review about tertiary amine. This nitrogen is connected to 3 other carbon. That's what makes it tertiary. So that's how you prepare amine. Okay. So the precursor here is ammonia. Okay. Ammonia is the precursor. You react ammonia with any alkyl halide, you're going to get an amine. Okay. Now, remember that? Tomorrow, I'm going to give you a lot of questions to do. I actually have 5 questions for you to do. And these are all pathway questions, meaning that they're not just going to be, here's 2 reactant, oh, what is the product? No. I'm going to give you a starting reactant, and you will tell me how are you going to get to my desired product. Okay? I'm going to have 5 of those for you to do. This will really test to see if you know your organic chemistry. It's fun, huh? Hey, this is all because I want to prepare you for the next test, which is coming. Okay? And you can bet your bottom dollar that you're going to see some of these pathway questions. Let's practice. All right, let's take a look at example 2. Example 2 is important. This type of reaction is called amide formation. Okay. Now, we saw that yesterday. Oh, now you know my passcode. This is not my iPad anyways. All right, we saw this the other day with esters. Okay, this is actually very similar to ester. The difference is one of the players. So you have a carboxyl reacting with an amine. Under the presence of some heat, you get amide plus water. Okay, so this is the general reaction, and let me give you a few examples, okay, a few scenarios to see how this will work. As I said, this is actually very similar to ester that we talked about. And yes, we need to know how to name these amine too. And the idea here is just like ester. All right, let's take a look at some examples. So example number 1. Let's start with one of my favorite carboxyl vinegar. Okay, ethanoic acid. I want to react ethanoic acid with methylamine. Okay, a primary amine. Now, there's a reason why I drew it this way. It looks like I drew it backwards. Of course I drew it backwards. There's a reason for that. Okay, it's because reaction will only occur when the two chemical is at the right orientation. Remember that? This is the right orientation. Because one of the product has to be water. And where's water is going to come from? Well, water is going to come from this OH and this H. These will come together to form water. Or this. That can happen too. Okay. So let me just erase this for 1 second. Okay. So having water being one of the product, the other product is going to be an amide. How is this amide going to form? Well, this carbon is missing a bond. This nitrogen is missing a bond. Say, hey, let's get together. Okay. Let's draw this back. So what you have here is CH3, C double bond O, N, CH3. All right. Now, this right here. Okay, this right here. C double bond O and C. C and C double bond O. This is called an amide. Just like how we saw yesterday, C double bond OC is called ester. This is known as an amide configuration. Now, this bond biologically is very, very important to biologists. This is called amide linkage. Okay, but biologists like to give it another name. Biologists like to call this peptide bond. I wonder if that name rung the bell. Okay, yes, it is the idea of putting amino acids together. Okay, when you have one amino acid reacting with another amino acids, it creates an amide linkage called peptide bond. Okay, there's this reagent, I think it's called Buret reagent, that have the ability to detect this and change the color of the solution purple. Okay, it's very popular in terms of testing for protein in the food industry. All right, so that's how you form amides. So that's the idea. Now, how do you name this amide? Well, no need to be afraid. This is how you name amides. So let's name this amide. Okay, the idea is just like ester. Okay, where you name the amine portion with a YL ending. Then you have a space. Remember, space is very important. Don't put spaces in organic name for the sake of just putting spaces, because spaces mean something. Okay, put dashes. So space, followed by the acid portion with the amide ending. All right, let's name this. Let's take a look at the amine portion. So let's name this part right here. The amine portion is this. Okay, this we will call midpoint. Okay, we will call midpoint. This is where it starts. So what we have here is a methyl. And that's it. And then you're going to have a space. Then you're going to name the acid portion, followed by the word amide. And the acid portion is only 2 carbons long, so you say ethane, followed by the word amide. Now, in most textbook nowadays, okay, even some old textbook, they tend to put the letter N in front of methyl. And you don't really have to, but I probably want you to get used to it because this is getting more popular nowadays, where they call this N-methyl ethanamide. Now, I'm sure you guys can imagine why N is, because this N is based on the fact that this methyl group is connected to the nitrogen. But if you think about it, this is an amide. This methyl group has to connect to a nitrogen. What else can it connect to? But, of course, a lot of textbooks like to put that N. A lot of bottles, chemical bottles, if you have a bottle of N-methyl ethanamide, you'll see this N. So, hey, just put that N in front. Okay. Alright, I do hope that you understand how to put together amides. I'm going to give you another question right here. Let's put this under a different color. I didn't use green that much. Let's use green. So question number 2. Okay, I have right here propanoic acid. Okay. Oh, I have right here ethylamine. I know I'm going to make water. What are you going to get other than water? What is the amide that you're going to put together? And how are you going to name it? So let's pause this video and figure it out. Alright, after I'm pausing, I do hope you know that water is going to come out from here. Okay, or here. Okay, doesn't matter. So let's draw the amide. So you have CH3, CH2, C, double bond O, N. There you go. Let me make this a little harder, actually. Let me just make this just a little harder. Okay, I'm going to take that H away, and I'm going to put a Cl over here. Okay, I guess you guys can do the same. Just to see, yeah, let's do that. Okay, make naming a little bit more challenging, just a little bit. But you know it's not that challenging. Alright, so how are we going to name this? Well, I do hope the fact that you wrote 1-chloro dash ethyl. Okay, now why? Remember what I said. You're going to use this N right here. Okay, is sort of like the count point. You start counting after this N. So just like what we saw with esters, there's going to be 2 carbon number 1. One going this way and one going that way. Okay, so in this case, this is carbon number 1, 2, 3. This is going to be carbon number 1, 2. So at carbon number 1, it is connected to a chlorine. You need to indicate that. And this whole thing is 2 carbons long with ethyl. Okay, let's continue with the name. So make sure you remember that you need a space after ethyl, indicating that, okay, I'm done with the amine part of things. Now I'm going to work on the acid part of things. And in this case, it will be a propan amide. Okay, and remember, put the N in front. Okay, all right. I'm sure you guys are comfortable here with amide. One of the things that I want to do with you now is to give you a couple of amides to name. Just the fact that you're recognizing these things. Okay, so here's one to name. Let me use gray. Okay. So I have this guy, CH3, CH2, CH2, C double bond O, and oh, let's do this one. Let's do this one. Okay? The reason that this came about, I hope you understand, is that you have a carboxylic acid, butanoic acid, reacting with actually a secondary amine. Okay? Because this N is connected to two other C's to begin with. So this is actually a secondary amine. Now, how are you going to put that together? I mean, how are you going to name this? Now, again, the naming is very simple. You name the amine portion first. This is a secondary amine. If you were to name the secondary amine, you would have said ethylmethylamine. But you can't really just say that, okay, in an amine situation. So in an amine situation, you will say N-ethyl, meaning that one of the nitrogen is connected to an ethyl. Okay? Dash, and the other N is connected to a methyl. So you're talking about this guy. Okay? Space, butanamide. Okay? Hopefully you guys are comfortable with that. Let's do another one. Use blue here. Now, let me ask you a question before we begin. Can a tertiary amine react with a carboxylic acid? Do you think that will work? Well, why don't you draw any tertiary amine and react that with the carboxylic acid, and then you tell me if that will work. Okay? I can tell you the answer right now. There's no reaction. All right, how are you going to name this? So pause this video and see if we can name it. All right, after unpausing, I hope you guys can see that you have N diethyl. Okay, so no need to say N-ethyl, so you can just say N diethyl, space, 2-bromo, okay, propanamide. All right. This is hopefully not something that you guys will have too much struggle on, I hope. Okay. Now, let's do one more. Let's cover all bases. What happens when you have this crappy situation? Let's keep the acid part simple. What happens if you have that? Okay, that there's side groups sticking out of the nitrogen. Now, that's not a big deal if you think about it. It's really not. Just like what you did earlier. Okay, just like what you did earlier. You're gonna come up with some order. Okay, in this question, you can see that this nitrogen is connected to 3 other C. This is special. This is from an acid. These are from the 2, I guess, the secondary amine. So what you might want to do if you have this situation is make sure that this is carbon number 1 and 2. This is carbon number 1, 2, 3. Okay, this is carbon number 1. So, whoa, look at that. You have 3 carbon number 1. But only, of course, these are taken care of based on the amine that this is reacted to. So, let's name this. Okay. What are you going to name first? Because what you're doing is that you're treating this as a methyl. Okay? You're treating this as a propyl. Alphabetical order now talks. P and M. M comes before P. So you would write here N-methyl. Okay? And then you're going to write in the other N is going to be 2-chloropropyl. See what I mean? Space ethane amide. All right. So don't be afraid of course, side group coming up from nowhere. It's really not that scary if you think about it. So that's, I guess, it in terms of amides. So the third reaction is really just the reverse of amides, okay, where you have amides reacting with water to give you carboxyl plus amine. So you have the reverse. So again, this is another hydrolysis reaction that we saw with ester. So let me just give you one example here. And hey, we're done with reactions. Next week, we're gonna look at a lot of graphs. Next week is gonna be a graph day. I have 4 graphs for you. Okay, we'll do 2 on Monday and 2 on Tuesday. All right, we'll worry about that next week. So amide. We have this amide right here. Okay. So propylethanamide. If you were to react this with water, hopefully you know that OH will come over here and connect it to carbon. This H will come over here to connect with N. Okay. As a result, why this is called hydrolysis is because there is a breakage in water, and due to that, there will be a breakage in your peptide bond. So what you're going to get is ethanoic acid plus propylamine. Okay. So just a reverse of amide formation. All right. I think that's it. Okay, there's not much. I don't think I need to give you another example. And hopefully you understood everything that we talked about today with amine reaction. So as I said, we're done with reaction. Tomorrow I'm going to give you a whole bunch of pathway reaction to work on. I have a little chart that I will also present to you. This chart is very useful. Okay, a lot of students find it very useful to have. Use that chart. That chart is like a little summary. It is a summary of all the reaction that we've looked at. All right. So have a good day, and I'll see you guys next week, and make sure you do all those questions tomorrow. Bye.